recording. All right, so what we're finding with doing, like, say we're going from state one. So in this example before, we were going from day 1 to day 3. So we were finding, like, after day 3. So what happened if I said you had to get to day 10? That's going to take forever, us keep going one by one by one. So what you can do is that create this rule for determining any state using the transition and the original state, like what happened originally. So here's the formula. So here, if you want to write here, the SN stands for any state that you'll want to get. So any state you want. And obviously where that little n is, that's like, so if you wanted state 3, it'll be S3. And so what you do is the transition gets raised to a power. So the transition raised to a power. So if you want to say, for example, if you want S3, then you will have the transition to the power of 3. Does that make sense? So, and then you times it by the original one. So say for, so let's have a look at the example. So I'll show you. Let's move down here. So a study was conducted to investigate the change in populations from Geelong and Ballarat due to the people moving between cities. At the start of the study, the population in Geelong was 250,000 and the population in Ballarat was 110. So it's probably good to put G and B next to it so you know the order. And then they said this is the transition of how it changes from year to year. So probably good to make sure that you are understanding that's Geelong and Ballarat that way as well. So it says using recursion. So when they ask you to use recursion, that means you have to show the step by step. And it's very important in year 12 because if you don't, you won't get the mark. So recursion means show it by step by step. So it says using recursion, predict the population after 1 year. So this transition is from year to year. So the state is a year. You know, so before it was a day, this is a year to year. So the way I'm going to find after one state would be state 1 year. I'm going to use the transition and I'm going to times it by our SO. So this is me using recursion. I'm using the one before. So I'll pop that into the calculator. Okay, so we've typed them in over on the calculator and we're finding out that we've got 241,500 now at Geelong after 1 year and 118,500 at Ballarat. Now, another thing to notice about these transitions, if you look here, if you totaled up the total population, you've actually got 360,000 in total. Okay, now it doesn't matter what state, when we're doing the transition like this, you should always have the same amount of people. So 360,000. They should always add up. They're just getting shuffled around. They're going from different places. So if we were to have other people come in, that would be another matrix getting added. So at the moment, it should always add up to the same. So there's after 1 year, and then they're asking us to use recursion to find it after 2, 3, and 4 years. So let's just write we'll just write the thing out, and we'll pop in the answers in a minute. So we've got S2 would be the transition, times S1, and we'd get an answer. S3 is going to be the transition times S2, and we'd get an answer. And S4, how many did they want of me? 4, would be the transition times S3. Okay. So that would be us showing it recursively. Now, just to show you how we can use the rule, I'm going to just use the rule now because it's going to make my life a little bit easier with not having to type it all up. So what I'm going to do is I'm just going to show you on your calculator. So when we want to find S2, so you could do, this is me finding it recursively, but over here, I'm going to put in here, if I was using the other formula where we go t to the power of n times SO, this one would be S2 would equal the transition to the power of 2 times SO. Okay, now I have that here. Oh, sorry. If I go over here on my calculator, there's the transition and there's SO. So what I'm going to do is raise that to the power of 2, press enter, and there's my answer. So I'm sort of doing it a little bit of a sneaky way so that I can get the answer quicker. 235,125 and 128,875. So there's what that one would have been. Now I'm going to do S3. So I'm going to copy the this over here again, but my power will change to 3 because I want state 3. Don't worry, mine's just on an exact. I'm just going to go control enter and there I get. Now we don't want to put decimal answer here. Why would I not want to put a decimal? What are we talking about? Yeah, we're talking about people. So we'll just round it to a whole number. So 230,343. Oh, sorry, 344 actually, because I want to round. So 344, and then if I will do the other one, 1, 2, 9, 5. Oops. 656, and if you add those two numbers together, they will give you 360,000. So that's okay. And then finally, we just want to get to state 4. So we could do it recursively like that over on the left there, or I can use the power trick. I often call this the power trick, and then we do that. So we end up with S4 ends up being 2, 2, 6, 7, 5, 8, and 1, 3, 3, 2, 4, 2. And if you added them up, they would end up being 360,000. So then in part C, it asks you to predict what's happening using the power trick rule for the population after 20 years and 30 and 40. So all we have to do for that, if I want state 20, the rule says I can do the transition to the power of 20 times SO. So I've got that over here on the calculator set up. All I'm changing is this power to 20. Okay, and then there's my answer. So after 20 years, it's 216,108 and 143,892. Those two numbers do add up to 360. So obviously if I want to find 30, I'm going to do the same thing but to the power of 30. So oh my god, sorry, I keep doing that. So up there, power 30. And then 30, that will be 30. So control enter, and then so let's add that one in, and then we've got 40. We'll do the same. Okay, so when we got up to after 40 years, we just had to be careful when we rounded up that bottom one at Ballarat, it actually rounded up to 440,000 because the 9s. Just remember, we've got to tally up to 360,000. So that's a way of knowing I've rounded it properly. So then that's what we're doing. Now, part D, it said to what do you notice about the population? So if you have a look, can you see it's not really jumping like we originally had 250,000 in Geelong. So if I just wrote the SO here so we can see it on our video, we had 250,000 and then 110. So we had, at the beginning, in the first few years, we had a big shuffle of people moving into Ballarat. But now you can look like, it sort of looks like it's staying the same. It's not changing as much anymore. And if you notice, if I go and do on this calculator, I'm going to go and see, what happened if I do, I'm going to do 80 years. And let's have a look at the answer. So 80 years, can you see, has it changed? It's actually the same number when you round it up. So what happens is what we call a steady state. You eventually hit a state and it's not going to change. So when they say D, when you can say, oh, what do you think, what do you notice about the population of Geelong? I think that the population of Geelong is going to stay at eventually drop down to 216,000 and then remain that. Okay, so we'll just say Geelong will drop to 216,000 and remain at that. Okay, and that, if you like, you can pop that, just so we'll probably talk about it, but you definitely next year. That's called the steady state, or what's happening long term. Okay. All right, I'm going to